Funny. But I've been here for, excuse me for a second while I delete this. Yeah, let's hope they don't call back. So yes, I've been here since 1990, so I've been here a long time, and I absolutely love South Africa. So I do geophysics here, and one of the things I study is magnetics. And so we're going to look today at the physical property of magnetics and susceptibility. How easy is it to magnetize something? Think about your fridge magnet. You know, you can just put a fridge magnet on your fridge, it's permanently magnetized. But think about a piece of wood. You can't really magnetize a piece of wood, okay? So that's kind of the concept of susceptibility, how easy it is to magnetize something. And so I want to show you some differences in some different rocks. So this is a little magnet, and it's going to tell us how magnetic a rock is. Well, this rock doesn't seem to be magnetic at all. It doesn't attract the magnet. Whereas this rock, which is a piece of ore from the Wits gold fields, this could have some gold in it, is magnetic, okay? So there's a little bit of, it's attracting it. Whereas this rock is super magnetic, and it can actually support the weight of the magnet, okay? So this is a very magnetic rock. So these rocks will have different susceptibilities. But I'm never going to get a scientific paper published if I say, this rock's a little magnetic and this one's a little bit more magnetic, right? I have to quantify things. So what we do is we use something called a susceptibility meter, okay? And this is a device that measures the susceptibility, that physical property of being magnetized. So let's go ahead and try. We checked with the little magnet and it said this one wasn't very magnetic. So let's see what the number is. Okay, we get a number of 1.63 for this rock. And then we're going to try this rock, which we know is magnetic from the little magnet. .502. So that's several orders of magnitude difference. And we get something like 14 different orders of magnitudes from the least susceptible materials all the way up to the most. So we have a huge range of actual numbers that we can use. But when a rock has a susceptibility, it interacts with the Earth's magnetic field. And what we can measure also is not just the physical property, but the magnetic field of the Earth. And so that's what we're going to do over here, is we're going to measure the Earth's magnetic field with our little airplane. So this is going to act as a little airplane, and it has a little sensor in it. A little magnetometer is in here. In fact, it's got an accelerometer and a rangefinder and all kinds of good stuff. It's called a Pocket Lab, and the app for the Pocket Lab, you can download that freely. Just look for Pocket Lab, and you can download it on your cell phone, and it will use the sensors on your cell phone. You don't even have to buy a Pocket Lab. I just bought it because I think it's a fun toy. I'm kind of like that. And so you can